Today on Pilot's Discretion, our guest is flight instructor, engineer, and RV owner Ed Wischmeyer. He tells us why angle of attack is overrated, how to prevent loss of control accidents, and what user experience means. Pilot's Discretion starts right now. Welcome, pilots. I'm your host, John Zimmerman, and thanks for listening to Pilot's Discretion from Sporties. You can catch up on every previous episode by visiting sporties.com/podcast, and you can email us at podcast@sporties.com. Today, I'm joined by Ed Wischmeyer. He earned a PhD at MIT and went on to work in engineering for many well-known companies, including Apple, NASA, and Gulfstream. He is an ATP and an instrument flight instructor with over 200 airplane types in his logbook. He has also written a number of interesting articles for Airfax, some of which we'll discuss today and we'll link to in the show notes. Ed, welcome to Pilot's Discretion.
Thank you. It's good to be here.
I have a feeling we are going to attack some sacred cows today, and there's no better place to start than angle of attack. So tell me why you think AOA is overrated as a cure for general aviation accidents.
Well, someday when you got a week, I'll give you the whole story. But there's a couple of phenomenon. One is the psychology of people who are looking for a solution, a single solution. So there's the psychology of people who are looking for things. The second is that angle of attack is a wonderful theoretical concept, but when you look at the implementation, there are all kinds of things that don't show up in the theory. For example, if you do slow, graceful, gentle maneuvers, we all know that pitch leads airspeed. And angle of attack sort of goes along with it. But if you maneuver vigorously, angle of attack leads pitch. So what this says is, depending upon how you're flying, pitch leads angle of attack, except when it doesn't. And how are you going to explain that to a student? And related to that is that angle of attack is very sensitive to G-load, hence turbulence. So if you're trying to use that for visual guidance, it's going to be jumping all over the place, and you're going to have to watch it almost continuously to average things out yourself to see what it's really telling you. And then another point is that general aviation pilots don't fly the same angle of attack all the time. Normally, sort of the book approach is 1.3 VSO, but for short fields, it's 1.2 VSO. So that's a different angle of attack. And then if you make adjustments for turbulence and winds and increase your speed, that's a different angle of attack. So you've got all these factors going on, and this is not even considering the human factors of one more instrument to watch. We train pilots not to watch the airspeed, but to fly pitch and let the airspeed catch up with it. That kind of works with angle of attack, and it can work in good circumstances. But what I found in my messing around with angle of attack is that I'll fly pitch and get the airspeed stabilized, and then I'll look at the angle of attack to see what it's telling me in calm air. So it's really just a mess in terms of the mechanics. I mean, the theory of angle of attack and stall, that's irrefutable. But it's also interesting that not everybody has all the facts straight. Many of the books say that when you get to the stall, the wing loses lift. Well, it doesn't lose all its lift. It loses a chunk of it. I forget whether it's a third or something like that. But the wing continues to lift post-stall. So there's people who are looking for pat answers, people who are looking for a single-point solution, people who are looking for simplicity. And the long and the short of it is they're trying much too hard to justify angle of attack.
A great reminder that one-size-fits-all solutions rarely work in something as complicated as aviation. Are there times when AOA is useful? So obviously Navy pilots will tell you how great AOA is when they're landing on a carrier. Are there times when a general aviation pilot should get something out of angle of attack?
If you've got everything calibrated properly, and that can be a trick to do for people who are amateur pilots calibrating systems, if it's properly calibrated and you absolutely need to have optimum performance, yes, it can be good for that. But what you need to do is make sure that you're flying a very steady profile so that you don't encounter the funny dynamics and that you really know all of the details. It's not just plug and play.
A lot of times this topic with AOA comes up in the context of stall spin accidents, loss of control accidents more broadly, and many pilots instantly jump to the dreaded base to final turn, which seems to have a special place in the nightmares of some GA pilots. You've written about this and have an interesting take on this, that pilots' fear of that scenario often causes a poor base to final turn. What do you think is really going on here?
What I think is going on is that instructors teach pilots to line up with the center line on base to final. And what they're teaching inadvertently is that if you don't do this, something is wrong. So there's the phenomenon of what are you actually teaching and what do you think you're teaching? Now, one of the exercises I have is, well, two exercises. One is the deliberate overshoot. So you fly through and you don't turn final until you've crossed the extended runway center line. And that is really eye-opening, especially for senior pilots. And then, you just do your 20 and 30 degree S turns on final, and you realize that the overshoot is not a big deal. The other point, which is related to it, is after doing this exercise, I have the student land not on the center line, but at some predetermined offset. So on a wide concrete runway, I'll say, land 2 expansion joints off center. And again, this gets eyes wide open. We're going to do what? We never do that. So what we're doing is we're attacking the history and the tradition, which, it's good practice, no doubt about that, but it's not an inviolate, the world's going to come to an end if you don't. So what we're trying to do is get the pilot comfortable in the environment rather than fearful about, I have to stick to the very straight and narrow because that's all I've ever seen, that's all I've ever done.
Now, at the other end of the runway, what I see a lot of times is an overlooked part of the loss of control debate is takeoff accidents or climb out accidents, which can be as problematic, if not more, than the base to final turn. This is an area you've done some interesting research on and sometimes lumped under the impossible turn heading, although that's quite deceiving. What you found I thought was fascinating was that almost 3/4 of these takeoff accidents involve an airplane that never really became airborne. They're not really an engine failure scenario. How should we train to prevent these accidents?
I think that I haven't really thought about this question, so I'm going to wing it here, if it were. But having a pilot who is comfortable on takeoff and is able to perceive everything going on. I remember when I was a student pilot on final, I was concentrating on the runway, and my instructor got at me and he says, I need you to look at the whole airport, see who's taxiing, see who's where, and have this general overall perspective. And I think that same sort of thing can go on takeoff because, things do happen fast. You want to check the engine power, but you don't want to take your eyes off the center line. I haven't really thought about that, but that's something that I will definitely look at. But I think it's just that you want to have a tremendous situational awareness so that you don't get overcome by anything during takeoff.
Both the base to final landing approach and the takeoff scenarios, do you think we're dealing fundamentally here with a proficiency issue that the pilots were taught correctly, but it never really, maybe it didn't sink in and they're not current at it, or were they taught improperly in the first place? In other words, do we need to address our primary training and how we're doing it in flight schools, or is it a matter of pilots just needing to fly more and stay sharper?
I think that the solution is to make pilots more comfortable and more aware of what's going on. The data that I've looked at suggests, and of course there's no way to find out after a fatal accident what the pilot was thinking, but there are all kinds of psychological phenomena, focusing too much on the runway and not paying attention to bank or not paying attention to pitch. There's also a considerable amount of evidence that suggests strongly that pitch control and bank control are two separate tasks. So you can be focused on one and neglect the other. So for example, if you're really focused on runway alignment, it's easy to neglect pitch and airspeed and all those things. And it's also well known that when pilots get stressed, all kinds of cues get dropped, auditory cues being the first ones to get dropped. A real interesting story is that back in 1925, an Englishman by the name of Louis Mogans, if I pronounced his name right, was interested in this same question of inadvertent stalls and such. But he had the foresight to recognize that if he gave people an oral warning, well, that might not get heard. And if he gave them a visual warning, that might not get seen. So what he invented and submitted a patent application for in 1925 was not a stall warning, it was a stick pusher.
An idea that has come back in many, many ways in most transport airplanes, and you rarely see in a general aviation airplane. One topic that comes up when we talk about these loss of control accidents is energy management. Some flight instructors love this concept. Some flight instructors hate it or don't even know it. The FAA seems to blow hot and cold on it, but they recently added an entire chapter to the airplane flying handbook on it. And you had an interesting article on Airfax you wrote. Part of it said, quote, "Aviation safety is too important to tolerate vague phrases like energy management." So why is that vague?
Well, it's vague in the sense of it's not immediately discernible in the cockpit. It's an abstraction. So nobody is going to say, gee, I'm too slow. Maybe I need to trade off some potential energy for kinetic energy. And how do you measure those? Well, you've got altimeter and airspeed. It's also interesting if you want to get into the sophisticated mathematics, and there's the Hamiltonian and the Jacobian, I think, are the two mathematical constructs. When you start off with those and differentiate those according to the way you derive it, what you come up with is airspeed and altitude. So yes, you can take all these things and make abstractions from them, but no. And I think it's Laplacian. I think it's Laplacian and Jacobian. I don't recall.
It all sounds too complicated for me. So are there concepts there that work?
Me too.
Are there concepts there that work, or should we just get to the basics of, one of the things I see often is just inability to control airspeed. So even if you don't have angle of attack, even if you've never learned energy management, if you just flew VREF on final plus 3 knots, minus 0 knots, I personally believe 99% of the time you'd be just fine. But I see many pilots who are unable to maintain that level of airspeed control. Other than that, what else should we be teaching? Some people say stabilized approaches. That's a key. Pilots in 172 should be flying stabilized approaches, like you might learn in an airline. Is that part of the solution?
There's a real interesting concept on stabilized approaches that I've just thought about in the last few weeks. All approaches should be stabilized, and the point of a stable approach is so that when you get to the flare, you can do the flare properly. Now, the real question is not should the approach be stable, but how long should it be stable? So the airlines say we want it to be stable from 1,000 feet or 500 feet. And by the way, they've changed their minds on that in the last few years. I know that in my RV4, which had powerful controls and I was really in tune with it, I wanted my approach to be stable for the last 20 feet. So the question is not, should it be stable? There's a question of how stable. Should it be stable from, 30 miles out or from 10 miles out or 5 miles out? And there are a couple of real interesting ways to look at how to measure how far out. One is distance, which is, doable. One is altitude, which is easier. But another is time to touchdown. And if you use the same altitude criteria for general aviation that you do for airlines, you're saying that you want your approaches to be stable for about twice as long. Another way of looking at it is to, if you've got the engineering mindset, is to look at the stability parameters of the airplane and measure your stable approach in terms of those. So, there's all kinds of ways of looking at it. But there's also the phenomenon that if the pilot is really in tune with what the airplane is doing, then the pilot doesn't necessarily have to be in a stable approach as long as he's really dialed in. The underlying assumption on a stable approach is that if it's really stable, the pilot will be tuned in. I had this discussion with an airline buddy, 20 or 30 years ago, and he told about how on one day when he was fat, dumb, and happy and not really paying attention, if you flew a beautifully stable approach and slammed it into the runway. And there are also cases that he was talked about where, the approach was fur and feathers all over the place, but he was really tuned in and he just made the most beautiful touchdown ever. It's also the case that if you look at unstable approaches, well over 90%, depending upon your data source, well over 90% land normally. And if you look at bad landing outcomes, whole bunches of those come from stable approaches. So stable approach is only part of the issue. And just to make a snide comment here, if your accident studies only look at unstable approaches, you can find some other things if all you look at is unstable approaches. For example, all of the recent airline accidents were turbine-powered equipment with 2 pilots, monoplanes, and tricycle landing gears. You can see where this is going. So this says that the solution to airline accidents is to have single-seat biplanes with tail wheels, or single-pilot biplanes. So you have to be careful how you look at your data.
I'll let you submit that comment to the FAA. That sounds like a winner.
Not till I'm ready to quit flying.
So, Ed, it sounds like you're not convinced that angle of attack indicators are the cure. And it sounds like you're not convinced that stable approaches are the cure, or that the concept of energy management is the secret. And I think you've given some reasons why. Let's take a quick break. And when we come back, I want to hear what you think might actually be helpful for solving some of these accidents.
Earn all your pilot ratings and keep your flying skills sharp with Sporty's Pilot Training Plus. This all-inclusive membership unlocks Sporty's complete library of award-winning video courses, so you can learn anywhere you have your phone, tablet, or laptop. For one annual fee, you get access to over $1,500 in courses, a smart investment in your flying career. Plus, enjoy free shipping every day of the year at sportys.com and apply for one of our 3 annual flight training scholarships. Learn more at sportys.com/pilot training. Now, back to pilot's discretion.
We are back with Ed Wischmeyer, who has developed a series of proficiency maneuvers that can help prevent loss of control accidents, what he calls expanded envelope exercises. So, Ed, tell us what the concept is here.
The concept is that you want pilots to have a large comfort zone so that when they're flying in normal operations, they're not anywhere near the boundaries of their comfort zone. I think there's an interesting statement to be made. I can't prove it, but I think that loss of control almost never happens to pilots in their comfort zone. They're out of their comfort zone in the sense of being distracted, being task saturated, something like that. So if you can keep pilots in their comfort zone, I think that's going to do good things for loss of control. I mentioned earlier that there's the problem in flight instruction that we teach them one thing when we actually think we're teaching them another. So the idea with the expanded envelope exercises is to show pilots, hey, you're nowhere near the limits of the airplane, so you can be comfortable with what you're doing. One of the real fun exercises, and these are all for normal category airplanes, so we're talking 60 degrees of bank max, 30 degrees pitch, 2 Gs and no spins, is the fast Dutch rolls. So at a speed comparable to what you would fly downwind at, so like in a Cessna 172, let's say 80 knots, holding a constant heading with the rudder, you use full aileron deflection and bank to 60 degrees, and immediately full aileron deflection the other way to 60 degrees. And what you're learning is that you've got all kinds of controllability in the traffic pattern at traffic pattern speeds. And if you need full aileron deflection, hey, you've got it. Well, this is not something you're going to use every day. But if, for example, there's a buzzard in the way or another airplane that you want to avoid, you want to know what you can do. And, this, like I say, this is not something you're going to practice all the time, but you want to know that it's not going to be scary. I flew with one young pilot who got his commercial through one of the big name national flight schools. And I asked him, what would happen if you put in full aileron deflection on downwind? And he looked at me quizzically and he said, would it spin? And, that's ridiculous.
So why not go do aerobatics or what some people suggest, upset prevention recovery, which is increasingly popular? Why do you think the E3 idea is better than those?
A couple of reasons. One is upset is really not the problem. Upset is an external influence, such as some meteorological phenomenon. But E3 is looking at pilot-induced situations where the pilot's fear of getting outside normal operating envelope is the issue. Also, E3 can be done in your airplane. I've flown E3 with pilots and everything from Cessna 150s to a Beech Baron, if you can believe. And, no aerobatics, no spins. And then the other thing is, in terms of cost, you can fly your own airplane for a whole lot less than you can go somewhere else and fly aerobatics. And then there's the issue of transfer. If you learn in an aerobatic plane and come back to your Cessna, well, how much of that aerobatic knowledge is actually going to transfer? What expectations have you learned in the aerobatic plane that are going to help you in the Cessna? And also, if you do learn the aerobatics, that's still not going to teach you things that E3 is going to teach you. For example, aerobatics is not going to teach you those fast Dutch rolls that I was talking about. So if you need full aileron deflection at low speed, aerobatics aren't going to help you because you didn't learn that in your own plane.
Yeah, I think about the transfer a lot. I fly Citabria a little bit, and that's got a lot better pitch response than a Cessna 210, for example. And I wonder sometimes how well those things transfer between them. Now, how about instructors? Can any instructor do this? Do you think instructors need special training? If I want to go do some of these exercises, what's my next step?
Well, I think the good examples are, one good example is mountain flying. Sure, anybody can go teach mountain flying and read the book and do it, but until you've seen it and sort of had somebody take you by the hand, you're probably going to miss lots of details. And the other thing is that since E3 focuses on different sensations and different sight pictures, an instructor is not likely to be able to teach those unless they've seen them themselves. And part of E3 is there are no completion standards. Like, you don't have to hold altitude, you don't have to hold speed to such and such. On the 90-degree turns, it's 90 degrees-ish, so you can focus on the sensations and the sight pictures. So if an instructor is teaching himself that, they're not necessarily going to know what to look for and be aware of what's important. So I think that one flight, or at most two, will teach an instructor what to do. And by the way, they'll come back from their flight with their eyes wide open. I didn't know we could do that. But the other interesting point about E3 is that after you've done these exercises, you say, well, that's not a big deal. And that's the point. Let me give you an example. One of the E3 exercises, and you don't want to do this with students below private because this is contrary to the ACS, is start off at cruise in a 30-degree bank and pull the power back and stay in a 30-degree bank. When you get to flap speed, put in full flaps, stay in the 30-degree bank. Stall it to a full stall brake, and when the stall breaks, don't shove the stick forward, just ease it forward a little bit. Stay in the 30-degree bank, ease in the power, and do the whole recovery. So you're doing this whole stall in a 30-degree bank. And it's like, afterwards, it's like, I didn't know we could do that, because all that's taught is the stall with the recovery and wings level. And then if the airplane is appropriately docile, you can do the same thing, but at the stall brake, roll it to a 30-degree bank the other way and continue the recovery there. And again, this sounds completely ridiculous, but it's not a big deal. So the point is that, yes, you want pilots to be aware of stall and to avoid stalls, but you don't want them to be afraid of them. And if they get into a stall situation, you don't want this to be the first time they've ever seen it.
Okay, Ed, at the end of every episode, we always close with the lightning round we call Ready to Copy. So I'll throw out some questions on a variety of topics, and I'm interested to hear your answer. And I have lots of different questions here. So are you ready to copy?
Oh, I bet you do. Go for it.
You told me in an email recently, quote, knowledge of the FARs should not be a game of Trivial Pursuit. Well, I agree with you 100%, even though some pilots I know would disagree probably. So what is the most absurd regulation that comes to mind for you?
I think the most absurd regulation is ILSs and MLS are precision approaches, which is a bad name, and GPS is not. And what are the three differences that it makes?
I would agree with that. Anybody that can answer that question, I'll give you $100. That's needlessly complicated. All right, how about let's give the FAA some credit. Is there an FAR that is good and is actually worth knowing, or at least if you can't recite it, know it exists?
I think the one on fuel minimums is a good regulation. It shouldn't be necessary, but people being who they are, sometimes they need to have a little bit of external reinforcement. It's one of those regulations that should not be required, but given some percentage of the pilot population, yeah.
The one I always quote is FAR 91.3, maybe the only one I quote, which is the pilot in command. Very short and sweet about the pilot in command being directly responsible for and the final authority as to the operation of the aircraft. A good reminder that you in the left seat, buck stops there. So that one I think the FAA got right. Maybe not coincidentally, I think that FAR was written in like 1956. So an oldie but a goodie. All right, Ed, many pilots I find are as rusty on their avionics as they are on their crosswind landings. We talk a lot about loss of control, but a lot of the times the pilot is task saturated because they don't really know how to work that new GPS. What would you suggest we do? You get one shot here. Should we mandate avionics user interfaces are standardized between manufacturers? Should we write better manuals? Should we require more training? Something else? What would you do?
Well, the cat is out of the bag when the early GPSs came out, and the only standardization was the direct-to function. But if you look at the industry standard for manuals, the industry standard for manuals is about a D-. My poster child for that, and this is not GPS, but on the Cessna 150 manual from, 20 or 30 years ago, on the paragraph on the parking brake, it told what it was good for and all these things. The only two things it didn't say was how to apply it and how to release it.
Perfect. How about voice callouts? This is something that started making its way into general aviation avionics cockpits recently. Do you think voice callouts are helpful or a gimmick?
They're worse than a gimmick. They're obnoxious. When I was at Boeing, I wrote the first draft of the document on what's appropriate for voice callouts and what's not. There are a couple of problems with voice callouts. One is that the first syllable is lost. It only gets your attention. And then the second is that the voice callout takes too much time and is too attention-getting. So, if it's something like your voltage is low and, you're intercepting the localizer, the voltage is low, you don't need that kind of distraction. If you look at the ASRS reports, there are a couple of things where the Honeywell RAS system interfered with ATC communication. So it's too violent a reminder to the pilot.
Runway incursions, another topic that's been kind of blown hot and cold with the FAA, but is an issue. There's been some high-profile examples of that recently. What's your one favorite fix that we could do to help prevent runway incursions?
Boy, there's a whole bunch of things. And in fact, some years ago, I wrote a paper on runway incursions that was actually circulated by the FAA at 2 runway incursion meetings that they had. I think that one issue that comes to play is that there's a real lack of standardization at different airports on runway signage, like is a taxiway sign before or after the taxiway. I had a friend at the FAA 20 years ago when the FAA started to get serious about this, and they put out their brochure, and it had, 10 or 15 points. He could point out flaws in each of those 10 or 15 points. So it's a very complex situation where standardization and simplicity are required.
You're an advocate for flight instructors speaking more clearly. You wrote, quote, "The pilot is the customer, so speak the pilot's language, not the dialect of the instructor." I say amen. What's an example of that? What's something that flight instructors are offenders on?
Angle of attack.
Or energy management. A flight instructor on final shouldn't say manage your potential energy.
Yes.
I might know the answer to this already, but I want to give you the chance to say it more clearly. What maneuver should pilots spend more time on during recurrent training? So if I think of the average flight review and all the things we're going to talk about and go fly, what's something that does not get enough attention?
I would say probably slow flight, not necessarily at the stall warning horn, but, slow traffic pattern speeds and turns, steep turns, being really comfortable in control at slow speeds.
That's a great answer. I think my vote would be too much time on stalls, not enough time on slow flight. If you're really comfortable in that slow flight regime, it's amazing how that translates. All right, this one's really simple. I'm sure I won't trigger you on this. Does pitch control airspeed or altitude?
I can have a lot of fun with that. I think I tabulated 30 different answers to that question. And the answer is, it depends. The dynamics of the airplane, the handling qualities, all kinds of things. Yeah, basically, choose your answer and there's a justification for it.
Once again, no simple answers in aviation. I like it. You owned an Aircam at one point, which is absolutely one of my favorite airplanes. Can you describe what it feels like to fly an Aircam for those of us who've never been in one?
Well, the phrase that comes to mind is sensory overload. It's not open cockpit, it's no cockpit. So you have the wind, but you also get the smells of the wind, and you discover that the air is not homogeneous, but you go through different little clumps of air with different temperature, and all this with this tremendous view. So it is sensory overload. And it's interesting to me that in terms of handling qualities, I'm not sure anybody cares what the handling qualities are because the sensory overload is so strong.
You spent a lot of time thinking about how people interact with technology. It's been a part of your career. And I thought you summed this up beautifully in something you wrote. User interface is doing things right. Usability is doing the right things. User experience is both. So can you translate that into aviation? What's an example of user experience in the cockpit of my Cessna 172?
Well, it's interesting to me that years ago, if you wanted to do an airplane checkout, the VHF radios, were 2 minutes worth, maybe learning the audio panel, but you spent all your time on the airplane. These days, the airplane is almost a secondary thought, and you spend all your time on the GPS and all kinds of things like that. And this gets back to, standardization and simplicity. But the other thing is that there's a whole bunch of functionality in the GPS, but you don't necessarily need all that functionality. I know that when the Cirrus came into the market, my local flight school had a Cirrus, but it was an 8-hour checkout so that you could completely master the avionics. And good grief, if you just wanted to fly VFR, all you really needed was Direct 2. So there's a case of tailoring the complexity to the mission.
All right. We always like to go outside aviation. And I noticed that later in life, you decided to take to the stage and act in a play. So I've got to hear it. What is a pilot skill that translates to theater?
Avoidance. It was very interesting to me that I had tremendous trouble learning my lines. And I discovered after the show was over that that's a phenomenon of age. And I had not been on stage for 35 years. So I think the lesson there is for older pilots like me, don't expect to go into a very complex situation with the learning skills that you had earlier. In fact, I read this once that some captain was talking about getting his type rating, and they were doing the final written test, and he was about halfway through, and the young flight engineers and first officers were done and gone, and he was still struggling with it. So the lesson there is realize your limitations in learning as well as others.
Our last question on pilot's discretion is always the same. You have one final flight, and we want to know, what are you flying and where are you going?
Well, I can tell you about my last flight. I was up and visited my sister and her family that I rarely get to see in Knoxville and flew back. IFR on top of the clouds, smooth, cool air, descended in the hot, bumpy landing, and made a beautiful landing. The tires just kissed the ground, put the plane in the hangar. I'm thinking, boy, this was really sweet. 2 days later, there was a fire in a hangar 2 down from mine. My plane was coated with soot and filled with soot. It's awaiting inspection to find out if the insurance company is going to total it or not. So that was my last flight, but I hope it's not going to be my last flight, because 4 days from now will mark 50 years since my first solo.
Wow. Ed, thanks so much for being on the podcast.
My pleasure.
Thanks for listening to Pilot's Discretion, brought to you by Sporties, training and equipping pilots worldwide for over 60 years. For more episodes and today's show links, visit sporties.com/podcast. I'm John Zimmerman. We'll see you next time on Pilot's Discretion.